Hey people, so this time I've gonna made a scale. Unfortunately, I didn't record any video while doing this because I had a lot of issues and I was kind of rushing it because I had to get it done within a certain time limit. Anyhow, this was made for the place where I work. We have a warehouse where we ship stuff. It's not a big warehouse, but it's a warehouse nonetheless. And when shipping stuff, we have to specify how much stuff weighs. Now we have a shop scale which goes up to 6 kilograms, and most of our stuff weighs 7 kilograms or more, so it's kind of useless. So I made this little fella which can weigh about 200 kilos. Well, this sensors kind of support it, but I tested it with my own weight, was about 90 kilos and held up. So anywho, um, what I've basically done is take a cash drawer, the kind used in stores connected to POS systems, and I took out the insides, I took out the feet, I cut some holes in the bottom of it, you can see them here, and I put in load cells, weight sensors they're called. I bought off eBay and used an HX711 24-bit ADC to output some useful data. I arranged the sensors in an Wheatstone bridge, I believe it's called, connected to the sensor, then connected to an Arduino Nano. Yeah, the tape is for, well, basically one thing is to keep the cables tied up, but there's a layer of tape on the wires, then there's a layer of tinfoil, then a layer of tape again to shield them from interference, because the thing about 24-bit ADC is that it is very susceptible to noise, and that reduced my precision quite a lot. Now here you can see my beautifully made Arduino Nano mod, and beneath the tinfoil overhead is the HX711, which you can see here, although it's outside because I didn't want to take my tinfoil off at the time. All that is for noise reduction. Also the mods on the Arduino Nano is for well, the big cap is for reducing noise on the power supply because it's powered via USB, and the resistor is for the button on the front, which is the tear button. It's very botched, it's not pretty, but it's not supposed to be moved around really, so I think it'll do. Now here you can look at the precision. It's basically plus minus 10 gram, which is horrible, but keep in mind that this does not have to be more precise than 100 gram. Because we only do 0.1 kilos at the lowest measurement, so it'll do. It's made for the job, Okay, so as I said, it's an Arduino project, so obviously there's going to be some code. Now, since this is not a very large amount of code, thought I'd show what I made. Yeah, I am self-taught, so this is not very pretty. Anywho, as you could probably see from the initial picture, it's got an 1602 display in the front, which I used this here library to control, and as for the HX711, that's the library right there. That's the one I tried to, that was the one I had the best success with. Anyhow, so what basically happens here is we set everything up, the serial, because it's continued outputting the weight on the serial port, so we can use that in our applications to work. Pin buffer button, LCD setup, and then an initial tear. Tear is, for those who don't know what tear is, basically zeroing the scale. So I take a reading here, or well, I take 10 readings actually. I do that continuously to set the weight to 0. I should include that actually. This average length. I'm not good at naming variables. Is the number of samples being taken each time it wants to display a number. Anyhow, basically what I do is I have an array of 10 values, and to the first place in the array I read the scale. Then I shift everything back one place, the data, and do the same again. I do that 10 times, so I get 10 readings in the array. where it basically inputs the newest number in front and the oldest number in the rear. Then I add it all together with this for function, and then I average it out. That's basically it. Then that's my TER value. I reset the LTD, put in the kilo sign, the kilo text up top, and then we get the loop. Here I do the same again with averaging. Every turn I shift the entire array one step back. I input the newest reading in the front, and I average it again. And so it goes. Now this crazy looking thing could be done better, I'm sure, but it was what made sense to me at the time. Now the scale, the readings from the ADC is going to one thing fluctuate due to noise. I have minimized that quite a lot, so that is fine, but it is also going to drift, and quite a lot actually. But yeah, it's going to drift based on temperature and how many evil spirits are in the room at a time. I don't know. It's annoying, but it is what it is. So I made this. This basically takes a minimum value I have set up here, which is 400. Now that may sound like a lot, but a 24-bit ADC puts out a number between 0 and 16 million. So it's usually floating around the 8 million mark when it's unloaded. So 400 is not that much really. Anyhow, I take that minimum value and I tell my if statements here that if the value of all 10, yeah, that actually breaks my number up here because I can't change that without changing the if statements. Anyhow, if all 10 values in the array I use for averaging is within the minimum value, e.g. 400, of my TER value, then we can TER again. Then basically that means we are compensating for the drift every cycle if the scale is unloaded. Because of the very low value, it won't affect my measurements really. It will perhaps take a few grams off, but I can live with that. That also means that if you leave something on the scale, it will not auto TER. So if you leave something on the scale for an hour, it may have drifted. It may have drifted. If you leave something on there for an hour, it may have drifted to such an extent that you'll have to reset the scale to actually get a useful value again. So that's a downside, but you shouldn't do that anyhow. So yeah, as I said, my army of if statements checks all 10 values in the array. Are they within 400 of 0? If they are, then TER equals the read value, that is the entire average read value. I also, and I kind of like this, it's not super precise, but it works. Now, I need to multiply the value from the ADC with something to get a gram weight. Now, I took the scale, lifted it up, read the value I get when it's in the air. Now, this will also drift, but this seems to be a pretty average value when it's not under any load at all. And I'm using this to basically have scale when it is unloaded, subtract the base value to get the value it gets from its own weight. Since the load cells are on the bottom, it will weigh itself when it is unburdened. So I use that to get a value which I divide by the weight, which is 4.025 kilos, to basically get the weight, the scale to weigh itself, and from that get the multiplier it needs to multiply the number from the ADC to get a kilo weight. And as I said, it's precise to within about 10 grams. So, yay. As I said, this drifts, so not always, but most of the time seems to work. So yeah, that's working pretty well. Now this user TER is for, as said, the button on the front is for tearing, basically zeroing out the value. if we have nothing on the scale, I want to set that to 0, so that is what we're doing here. Now for user tearing, there are two parts. There is a similar function to this tearing, but for user tearing. So basically it'll set the user tear on every cycle, but only when user tear is above 0. So if that has set it to 0, this won't be run at all. And that takes the user tear into consideration when doing the scale multiplier. Now to implement the user tear to begin with, we have this whole area basically. So when you push the big red button in front, it'll say tearing, then it'll wait for 2 seconds. I did that because when you push the button, since it is on the scale itself and the entire scale is being weighed, I put that in that delay so you have time to press down, remove your finger, and cancel out any wobbling on the table or whatever before it actually starts tearing, otherwise you'll get a false value. Then it does the whole same averaging thing again to get the user tear value, and now user tear is above 0, so this will come into effect. And since there's something on the scale, that means that the value will not be within 400 of 0. So this won't be run, and this will be run when it is teared. And there's something on the scale. That is, if you take something off the scale, then this will run again, user tear will be set to 0, and this won't run anymore. Once that is done, it goes back to its usual business, which is this down here, where we print out the value. That is, this little thing is because even though I have set my print function here, the comma 2 out here means that it will print the value I put in here with 2 digits, but sometimes, I don't know why, it prints 3. So I print 2 spaces to basically erase the third and fourth digit, third and fourth digit every cycle. Because this display will, if you don't write something to a square, it will just keep whatever value is there. So you may, if it goes to 23.025 and the next value is correctly only 2 digits, like 23.01, then that 5 in the third digit will stay there. So yeah, that's a bit of a hack to get rid of that. Now I think my library respects the HX711's 10 Hz, meaning 10 outputs per second read rate, but just in case I put in a delay for 0.1 second here. Not sure if it's necessary, but it doesn't really do any harm. And yeah, that is basically a poor explanation of my code here. Now, anyone who is, probably trained in coding in any way will probably think this is absolutely awful, but it works, and that is my goal. I don't do pretty, I do functional. So yeah, I think that is actually it. I don't really have anything else for the video. That is my entire explanation. Anyhow, that is all, I guess. Sorry for the slideshow, but thank you for watching. See you next time.